Hello everyone, welcome to the course Structure Analysis. I am Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today we are at the 30th lecture and we are going to discuss about analysis of 3 hinged arches. So far we have discussed about analysis of 2 hinged arches, which is statically indeterminate structure. But coming to the analysis of 3 hinged arches is statically determinate structure. So that is the main difference. So the problem solving time for the analysis of 2 hinged arches is tedious, it's going to consume lot of time. But in case of analysis of 3 hinged arches, the calculation of horizontal thrust, the time taken is comparatively less. So lecture 30, this is the first lecture on analysis of 3 hinged arches. At the end of the lecture, student can able to analyze the 3 hinged arches subjected to UDL throughout the span. So this is the beam, this is the 3 hinged arch. So first of all, I will locate where and all the arches are located, the hinges are located. We have one hinge at the support A, and then we have the hinge at the crown, and also we have the hinge at the support B. That's why it is called as a 3 hinged arch. Now let's compute the value of horizontal, let's calculate the values of reaction forces first. So for calculating the reaction force is very simple for this problem because the UDL is throughout the span. Because of that, it is a symmetrically loaded arch. So in order to calculate, we need to calculate the total load. Total load is, this is the UDL, so W multiplied by L. So WL is the total load. VA is equal to VB since it is a symmetrical section. So WL by 2 is nothing but VA. So VA is equal to WL by 2. Now I am supposed to calculate the horizontal thrust. So for calculating the horizontal thrust, just now we calculated the VA value is equal to WL by 2. Now we are going to take the moment at the crown. We are going to take the moment at the crown. At this point we are going to take the moment. The reason we are taking moment at the crown, because here the bending moment is 0. At any hinges the bending moment is 0. For example, at the point A the bending moment is 0 and at the point B the bending moment is 0. So since already known value at the crown of the arch the bending moment is 0, I am planning to take the moment at this point. So VA value is WL by 2 multiplied by this distance is L by 2. Overall span is L, up to this it's L by 2. So WL by 2 divided by L by 2, force multiplied by the horizontal distance is a moment, and then this H multiplied by small h. So minus of H multiplied by small h. What is the reason? Because this H rotating in a anti-clockwise direction. So force is here horizontal and the distance is vertical axis. So I will draw the clear diagram here. Our horizontal force is acting in x axis, and then this is the height of the arch. So force multiplied by the perpendicular distance is a moment. So h into small h. Okay, then minus, we have the UDL which is acting in a downward direction here. We need to consider this UDL also. That UDL is W multiplied by how much distance it's acting? L by 2. Because we are taking moment at this point. Multiplied by L by 2 divided by 2 is L by 4 equal to 0. So in this I want the value of horizontal thrust only. So minus of capital H into small h is equal to, I am taking this value outside the equal to, so this became WL L square divided by 8 plus WL square by 8, and then this term will come this side. So this is minus of L square divided by 4. Let's multiply the entire equation with multiply entire equation with the minus sign. So it will become capital H into small h is equal to W L square by 4 minus of W L square by 8. Okay, just I am multiplying the values. So this negative term will become a positive and then positive term will become the negative. Now h into capital H, I just want to multiply 2 in numerator and denominator so that I can able to subtract the value. So 2WL square divided by 8 minus of WL square by 8 will be getting, the answer is WL square by 8. So this is capital H into small h. Therefore, capital H is equal to WL square divided by 8 times of H. So this is the horizontal thrust of a 3-hinged arch subjected to UDL throughout the span. So next we are going to calculate the bending moment at any section. So we are going to prove bending moment at any section is 0. Let's mark the section first of all. I am considering the capital XX section and then the linear distance is small x. This linear distance is small x. I am going to calculate the moment. What I am going to calculate? I am going to calculate the mx. Mx represents bending moment at this XX section. I am going to calculate equal to, write down all the values. We know the VA is equal to WL by 2. Then we calculated the horizontal thrust. The horizontal thrust is WL square divided by 8H. WL square divided by 8 times of H. Okay. And then at this point the ordinate, this ordinate y. So what is the y value? Y is equal to equation of parabola 4hx into L minus x divided by L square. So this is the equation of parabola. We can measure the vertical ordinate anywhere across the 3-hinged arch. Now mx is equal to force multiplied by the horizontal distance. So WL by 2, this force WL by 2 multiplied by x, linear distance. So WL by 2 multiplied by x, and then this force having the perpendicular distance here, and then this force. What is this force? This is minus of WL square divided by 8 times of h multiplied by this y. The y value is this one. What is that? 4 times of hx multiplied by L minus x divided by L square. Okay, and then we have the load also. We are supposed to calculate that. So the load is acting in a downward direction. That should be calculated. So minus of W multiplied by x. Since it is a UDL where it will act at the distance of x by 2. Okay, let's simplify this. Mx is equal to, I can say this is WLx by 2. And here what are the terms can be cancelled? This 4 and 8 we can cancel, that is 2 times h and h will be get cancelled. This L square and L square will be get cancelled. Then what is the remaining term will be there? The remaining term is minus of Wx into L minus x divided by 2. Wx into L minus x divided by 2 minus of W x square by 2. Okay, further we will simplify this. WLx by 2, multiplying this term inside the bracket. So I will be getting WLx by 2 minus W x square by 2 minus W x square by 2. I am just multiplying Wx into L. So WLx by 2, then Wx into minus x. So minus of W x square by 2. Now you can able to see that this term and this term will be get cancelled. Actually here it is plus, here it is plus, the reason is minus multiplied by minus, it became positive. Okay, so these two terms are cancelled, as well as you can able to say these two terms are cancelled. So obviously we are getting the mx is equal to 0. So this is an interesting concept, because if you consider the two hinged arches, we are going to have the bending moment. If you take anywhere across the cross section, there will be the bending moment. But if you see here, the bending moment at the XX section is 0, because whenever there is a hinge, that is not going to allow transfer of any moments. Okay, so that is the advantages of the three hinged arches. So if you take anywhere across the X section also, we are going to get the bending moment value is 0. So in this problem, we have calculated the horizontal thrust. Also we know how to calculate the bending moment anywhere across the arch. So thank you for watching this lecture. Thank you.